In this video, I will teach you how to compute questions on method of moments when given this type of data. Here, we have a question. A website recorded the time in seconds between clicks for 10 users. Model the given data. This is the data using method of moment and estimate the parameter lambda for an exponential distribution. Solution. For more on this topic, you need to subscribe to this channel. Now, we are asked to model this data for an exponential distribution. We should recall that if x follows an exponential distribution of lambda, it means that the expected value of x is equal to 1 all over lambda. That is what it means. And now, for the method of moment, the solution of the method of moment means that we'll have mu 11 to be equal to m11. What does this mean? Here, means the population mean must be equal to the sample mean before we'll get our answer for the method of moment estimation. So we move over to this side of the board. If we have mu, which is our mean, to be equal to 11, it then means that our expected value, because mean is equal to the expected value of x, our expected value will be equal to the sample mean. What is the sample? The sample mean will give us 1 all over n summation of xi. And this thing here means x bar. So it means that for our method of moment for an exponential distribution, we have our expected value to be 1 all over lambda to be equal to our x bar. That is what we get if we are estimating it. Now, what is x bar? X bar is 1 all over n summation of xi. Now, we look for x bar, then we now compare. So it will mean 1 all over lambda will be equal to our x bar, which is equal to 1 all over n. What is n? We have 10 users. If we count the data here, it's 10. So we have 1 all over 10 into, we'll now add the whole of this, because the summation sign, this is xi value. So we add 12.5 plus 5.8 plus 22.1 plus 10.3 plus 7.9 plus 15.6 plus 30.8 plus 8.5 plus 18.2 plus 12.1. So this is what we have. It then means that 1 all over lambda will be equal to, we have to add the whole of this and divide it by 10. So we'll add the whole of this. Adding it will give us 12.5 plus 5.8 plus 22.1 plus 10.3 plus 7.9 plus 15.6 plus 30.8 plus 8.5 plus 18.2 plus 12.1. So we have 143.8 all over 10, which is equal to 14.38. So we got 14.38. It then means that 1 all over lambda is equal to 14.38. But we are not done here. We still need to write the estimate for lambda. So to get the estimate of lambda, we move over to the other side of the board to do that. So move over to this side. For more on this topic, you need to subscribe to this channel. So we have, if we have 1 all over lambda to be equal to 14.38, it then means that our lambda estimate for an exponential distribution, while estimating using the method of moments, will have here to be 1 all over 14.38. So what is 14.38? 1 all over 14.38. So we use our calculator to check. 1 divided by 14.38. So we have 0.0695. So we have 0.0695. That becomes our estimate. So it means that for every second recorded from our question, it means that for every second recorded, we have an estimate of 0.0645. We have an estimate of 0.0645. So this is how we can compute the method of moment for an exponential distribution when given data like the type we have here. For more on this topic, you need to subscribe to this channel.